that a countdown timer to go home?
If we're lucky.
Or the
If
clock to go off, the power
yeah.
to go off 2 hours and they send us home.
Yeah. So you can work at home.
Yeah, it's better.
Yeah, yeah. Kind of light today.
I can eat my snacks all day.
Yeah. Yeah, me too. It's dangerous working at home. Do you know if any of the other fire guys are going to be over there, Aaron? Or going to show up over
Um,
there?
I don't know. I can ask him.
No, I mean, it's
Let
fine
me-
if they're not. I just was going to start
Oh,
either way. Yeah.
oh yeah.
Okay. Well, I'm just going to get started. We're recording anyway. Okie dokie. So today we are going to do a kind of a speed modeling session for families. Last week we had a kind of a beginner startup for families, modeling families and things like that. This is going to be less of an instructional video and more of a kind of just a demonstrational video. Yeah. So I have right here. I have an air handler. We will build a hot water storage tank, a mixing valve, a chiller. Oops, I think I want. Oh, I didn't pull down the chiller yet. We'll see if we can get to the chiller, and then we'll do an air handler too. Maybe we'll do a chiller at the end if we have time. Yeah. Okay. So I'm just going to go ahead and get started. We can start with the hot water storage tank. So the shape of this tank is kind of funky. Hot water storage tanks to me are kind of fun to build. When you look at this, you always want to break down families into their primitives. So here's a cylinder, and then you have kind of a dome on the top and a dome on the bottom. And then however we end up doing the legs, maybe the legs are some sort of an L bracket extrusion. And then all the connectors are just cylinders, basically. Yeah, so just to kind of recap what we looked at last week, everything is built with primitives, and then you just kind of add the primitives together. I don't normally run voids very often in families unless they're like air devices and things that need voids inside of them. I mean, by rights, you could put a void on the inside of this, but it wouldn't really do you any good. Yeah. So let's go ahead and get started. I'm probably going to fudge a couple of the dimensions here just for the sake of time, but you guys kind of get the drift. So really what we're looking at here is a diameter of 54 inches, an overall of 115, and then 85 inches. So yeah, maybe we'll post something on the side or something, but I'm just going to leave this on the other screen and then we'll just get right into it. Yeah. So again, what you always want to do is build your reference planes. So here's a front view. We'll do a reference plane for the bottom of the cylinder, the top of the cylinder. Here's the bottom dome and the top, or I'm sorry, the top dome and the bottom dome. And if we were really going to get into this, we would add dimensions to all this and kind of fill it all in, kind of like this. So this is the start. If I take 85, so we'll do 115 minus 85 minus 15 minus 6 is 9 inches. So this should be 9 inches. We'll lock it. This is going to be 85 inches. This one here, we'll lock this one just to keep these in place. This is 15 inches. And then this should be 6 on the bottom here. We'll lock this one. And then 6 inches. Okay, so that kind of builds our beginnings here, yeah? So from a plan view, we'll make our cylinder. We're looking at a 54-inch diameter on this, so we take our dimension. And we don't necessarily need to have dimensions on these, it just makes it a little bit faster to model that way. And again, you always want to draw your planes in first, and then draw to your planes, put your primitives onto your planes. I like to use revolves for domes and things like that. So you can kind of see, since I had all of the planes and everything in there, it'll kind of snap to the planes for you. So here's your half dome. We want to make an axis line here, which will be in the center, and then we can kind of trim these in here. Another, boundary line, draw it up, ba-boom, and then I'll split this and trim these in. Click OK. So we can see how quickly we're kind of building, our whatever you want to call this bad boy, our primitives. And then here we should be able to mirror this like this. Move it up. Actually, I'll just draw this again real fast. Create a revolve. Domes. But again, if everything's kind of drawn in here from a reference plane perspective, it actually makes this really easy when you start bringing everything together. Yeah, like as far as these domes can take you a while to build if you're not kind of used to them. So there's kind of what the main tank look would be based on our submittals, or based on the submittal. So let's go ahead and build the legs real fast. This has 4 legs on it. So from a plan view, I'll just draw a reference plane out this way and then create an extrusion. Now there's lots of different ways you can do this. I'm just going to make a cylinder here for a leg. Doesn't matter what the dimension is, because this is just kind of down and dirty here. And then from a top view, from a top view you can start mirroring these across. Mirror, mirror on the wall, and then we'll start doing the outlets. So the outlets themselves, right, you got a 3-inch on the bottom. These are in the same plane. You have your manway here, it's on a different plane, and then some other ones here. I'm just going to pretend that these ones on top are kind of the same plane, and then we have, what is this, 1, 2, 3, 4 openings on the top. So we'll do these ones here. I think it said it was 6 inches. So you can see when you grab these reference planes, you don't necessarily have to have a dimension, or you can click on this and it'll make the dimension for you. So if you don't have one, you don't actually have to go and, dimension this and then put it in. But there's lots of different quick ways to kind of get that in. So extrusion here, boom. And again, if we were actually going through the time to do all this, I would add labels to everything. So maybe this is outlet 1. So outlet 1, and then we'll just make that type-based. But this is supposed to be 3 inches from the submittal, ba-boom. And then from a top view, then you can kind of just drag this out. This is probably pretty good. When you go to add in your connectors on something like this, from a modeling perspective, you'll kind of see these stick out. What I do a lot is I'll go and get the actual dimension of like a 3-inch half coupling, because that's actually how they build these. And maybe, I'll just like hide this and I'll add the connector to the back of it. Yeah. So I'll put the connector on the back and then I'll flip it the other way. So it's a little bit of a fake connector if you think about it that way, but the pipe will actually go into the half coupling here, yeah. And then we could map this if we wanted to outlet 1, so everything kind of matches, yeah. That way, if we change the outlet 1 dimension to 6 inches or whatever, the extrusion and the connector both move at the same time, or they flex at the same time is probably the proper term. So if we go back to our front view, we had one on the front and then there's one on the right. We can still use the same plane because they're in the same plane. And then it's kind of always just the same thing. I'm not going to add dimensions to all these. Maybe this one's 2 inches. And you can see how it defaults to radius. So kind of just be aware of that. It will always default to radius when you're looking at round things. It's just kind of how the software operates. It's kind of always been like that. And again, you always want your planes. Yeah, you always want to use reference planes for everything. Constrain your objects to reference planes. And you can see here, even if the reference plane doesn't extend, it'll kind of do your object snap tracking here. So maybe this is a 4-inch outlet. Ba-boom. Oh, and we can't see it here. The reason why you can't see it is it's outside of the technical view range. And I don't know why it does this, but if you go to the ref level, you can see it, and we can kind of extend it. Another way to kind of get that into view here is if we didn't want to use the ref level, you can just use a different side of the cube, as it were. So I'll just go build a couple extrusions for the top, and we'll call this one good. Actually, we'll do the manway too. And again, you don't have to do all these independently. The reason why you would want to do them independently is if they had different extension lengths. And what I mean by that is if they stuck off of the tank separately. So if we go to the front view now, we can go ahead and drag this off, kind of stick out slightly here. And then if we look at our doghouse here, this is kind of what we got. So we built this tank pretty quickly. Let me put the manway on here. Excuse me. Let me put the manway on here. And usually that's an extrusion like this. And again, I would follow whatever reference plane I would have is usually the best way to do this. Kind of stick this out here to the face. And then if we were going to do some clearances, these are real big for equipment. You always want to show your equipment clearances on here. We want to do that with model lines. So we want to grab the line actually. Boom. And right now we were at 54, I think. So you could say equals 54 inches divided by 2 plus whatever the clearance is. So we'll say 18 inches. So it does all the math for you as you put it in. You just have to put the equals in the beginning. Okay. And then the other thing that is useful for storage tanks or required for storage tanks is the 5 foot in front of the manway. So we go 5 feet. Oops, we want to make that straight. Boom, and then you can trim this in. So here is our storage tank. We built this pretty quickly actually, and this is very useful not only from a modeling perspective, you know, a design perspective. You can add whatever connectors you need on this to you know, for your engineering, sizing, etc. Yeah. Any real questions on this before we move on to the next thing? We built this one pretty quick. Nothing? Okie dokie. Let's do another one. So next one up is, we'll do this mixing valve here. Mixing valves are something that are kind of hard to find online. I've spent a lot of time modeling these before. Whether it's required or not is really kind of a, I guess it's up for interpretation. You don't normally get a whole lot of very good information on these mixing valves, and some of these mixing valves you have to build yourself with like valves and PRVs and all that stuff. I generally don't do that. One, because from a bill of materials perspective, you don't need all that. It comes as a package. And two, you know, it's just probably not that necessary. So for this one, you know, we'll just put some tubes on here on the face, and then we'll add the strut on the back, and then we'll add some ways to kind of flex this so we can make this multiple valve types if we wanted to. Okay, so we're looking at 28-inch centers. We'll do the outlet right in the middle, and then we have this 27 by 38 strut on the back. Okay, so from a front view, I'll build my box first for the strut. Okay, and I'm going to use the origin of the ref level as my bottom. So it said 38 inches. I'm sorry, this one's 27 inches. This one here, we need to do an equals constraint. Boom, boom, boom. And then after you do that, it won't kind of let you go in here and change this. It just doesn't like to do that, so you have to turn it into a parameter. And by rights, you should be turning this into a parameter anyway, but you know, sometimes if you're in a hurry, it just doesn't make sense. I usually always make parameters, whether they're worth, you know, the time or not, I don't know. But if I'm making a family, usually it's worth the time to actually do it. Yeah. So we'll do, oops. Here's our strut assembly here for the back, just the outlet. Now you could go in here and we could do an offset, and that strut is 1 5/8. 625 inches, and I can go over this, and if I hit tab here, it'll do the whole background or the whole square since all the lines are connected. So there's our strut cage, yeah, and then from this is a front, from a top view here, you know, this is 1 5/8 strut, so you can set your extension here to 1 5/8, yeah. So there's our strut, I don't know, rat cage assembly, whatever you want to call it. Let's go ahead and build our tubes that sit on the front. So here's where you can start getting into custom UCS planes. So if we go here and we say, hey, this is our pipe center line, we call this plane our pipe center line, and then from the front view, we want to set our work plane to say pipe center line because we named it. Now everything that we draw is going to be on that work plane. Okay, so I'll draw a reference plane here. There's our left outlet and our right outlet. Oops, I'll just copy this one. Our left outlet and our right outlet, and then we'll just use the origin as the center. So we're going to assume that we have a 28-inch center on this thing, and then the outlet comes out the top, yeah? So we'll do an equals constraint again here, ba-boom, and then we'll go ahead and dimension this, and we'll say center to center, and then it's supposed to be at 28 inches, babushka here, and then we can go ahead and do, we'll do a sweep just for fun, yeah. So to do a sweep, let's put in another plane here. And this is a dual one, so it's a little bit more complicated. I'll make it a little bit easier just for the sake of time. But you can kind of see here how we have our U shape here and then our thing coming. It's almost like a pitchfork, yeah. So we'll do a sweep and we'll sketch our path right along our planes here. I don't think it'll let us do that. Maybe we do that one separate. And then we click OK, and then we'll edit our profile. We cannot see the profile in this view, so we got to go to a different view to make the profile. This will be the diameter of the outlet. So if we grab this and dimension it, you know, we'll just assume that this is a 2-inch outlet. So 2-inch, so we'll say pipe size, yeah. Make it instant space for fun, and ba-boom, and ba-boom. So there's our U shape there, and if we wanted to, pipe size, excuse me, now we're at 2-inch, we can see how it does that, and then we'll do one more sweep, just for fun. Sweep, sketch path. So there's our path there, edit profile in a 3D view, and it's another circle right on this plane, that gets dimensioned out at our pipe size. Now, a lot of times on these mixing valves, the inlets and the outlets are different sizes, so obviously you'd have more than one parameter probably. But just kind of be aware of that. And you can see how the sweeps got put on our plane that was current in the front view. So I made all of these sweeps in the front view with the pipe centerline plane as the current plane. And then if we wanted to, you could add another dimension here and say, hey, this is our offset, or, you know, centerline offset, whatever you want to call it, yeah? And then depending on the pipe size, maybe the centerline offset is 2 inches or something. That doesn't look right, so maybe 3 inches. Oops, inches. Ba-boom. That looks a little bit better. And then if we wanted to, we could go ahead and make our pipe connectors. So pipe connector, pipe connector, pipe connector. And these will all kind of go based on the right system. So you always want to check your systems. This is important for making families. Hot's always on the left on these, cold is always on the right. That's what you learn as a plumber. Hot's on the left and Friday is payday. That's what's important. Okay, and then again, you probably want to label these. So we would call this hot water inlet. I spelled that properly. Cold water inlet and hot water outlet. Ba-boom. Yeah. So there's our mixing valve. Again, it's not as fancy as what this picture shows, but it gives you the general idea of what you're looking for, yeah? If you're dimensionally accurate, that's what's most important. Actually, not only the dimensions, but, you know, volumetrically as well. You want to make sure you're saving the proper space and that you can install what you're planning to install, if that makes sense. You want to make sure that you're planning properly. Yeah, you don't have to over model things, but don't under model them either, and make sure that you always understand how these things get installed if you're going to model them. Okay, any questions on this one? Nothing? Okay, so let's get into air handlers for you sheet metal guys. So what I have made for air handlers is I have these generic boxes, okay, and I kind of call this the box method. And the reason why these are important, they have some symbols and things on them, but this is a really easy way to make air handler units, especially large ones, and then we'll get into some more sort of advanced type connector adding and things like that when you get into boxes. So we'll say File, New, Family, Mechanical Equipment here, boom, boom, boom. Cool. And then what does this one have? This one has, this is a really simple one, but you know, other ones have like UV filters and stuff. This only has 4 sections. You got a fan section, a coil section, a filter section, and we'll just call this a UV section just for fun. Yeah. Okay, so and we're going to need a door, a coil section, a filter box, and I think a mixing box is really what we're looking at. I thought we had a fan section. And we'll just add all these in here. So it's going to try to open these. I wish it would just load them in, but I guess it is what it is. And I think this is family 3 is what we're looking for here. Yeah, family 3. So load in to family 3. Close that. Here's our door into family 3. Here's our coil section. And we don't normally do heating. That's why there's a negative on here. I should probably do a positive one of these days. But usually we have cooling coils here. We don't normally have what you would call heating coils. We do have reheat coils and stuff, but yeah. Okay, so we have our basic building blocks, yeah? Now, this is where you have to make a decision on how you're actually going to build this air handler, okay? Is it going to grow from the middle out, from the corner out? Really, the only reason why this matters is because of how you're actually going to insert this. I generally recommend making sure the bottom is the bottom. Now, as far as if you're going to build it from the right out or the left out and the middle out, I don't think it matters for large air handlers unless you have a specific task. But usually it's the easiest just to start from the corner and grow outwards. If you do like a middle out type thing, then it gets a little bit more complicated because you have to do the equals constraints and stuff like that, yeah. So the way that these boxes are actually made is each one of these boxes has a length, width, and height. Okay, so when you look at the width of an air handler or even the height of an air handler, okay, so the height of this is 70 3/4 minus 6 inches. So you're looking at 64 3/4 height for every single one of the boxes, and then we'll add a 6-inch rail on the bottom, okay, and then the width is 100 inches for all of these. Okay, so we can actually go in here and make a parameter, and we'll call this AHU width because it will get mapped to all of the boxes here. Width, right? And then the other ones we'll have is AHU.length, which this one isn't super critical, but when you make your rail on the bottom, it'll be useful. And then we have AHU height. Another one you will have is rail height. So I'll just call this rail height. Sorry, the E key on my keyboard needs to be fixed. So 6 inches is our rail height. Our AHU width based on the submittal is 100 inches. The overall height for the air handler was 64 3/4. Oops. Come on. 64.75 inches. And then the overall length is 139 7/8. And again, oops, I should have done inches. Why this matters is just the way we're going to make the rail, and it'll allow us to check our box lengths at the end. Yeah. So the parameters are added. Let's go ahead and add the reference planes that we need just to make our life a little bit easier. And again, this is mostly for the rail and checking. So we'll go ahead and dimension this and this. This is our width here. And you can see since they're already added, they're available in the list. So our air handler unit width is here. This is going to be our air handler length. Ba-boom. Here, and then we'll start in the corner. Yeah, so this one, I'm going to build it left to right. The first one will be, the first one will be our box. I think I called this a UV coil just for fun. So this will be our UV coil. So fan or equipment housing, UV coil, cooling coil, and filter. Okay. So what is this one? Filters in the back, cooling coils up next. UV section is here. And then, oops, I didn't get the equipment housing. Let's do the equipment housing. I thought I had a fan section. I'll need to add a fan section to this with a symbol on it. Ba-boom. Cool. Okay, so let's take a look at here. So we can see how we have width, length, and height. Let's go ahead and map the height and the width to all of these. So the width on this box is the width. The height is the height. Ba-boom. So it's a little bit tedious to get the mapping right, but it actually comes out real good. Next section here, width is the width. And by rights, I should probably make a template inside, or have these templates loaded into a template, but I think you'll find that a lot of this stuff is built differently a lot of times. And then the width is the width, especially if you have like a double stacked air handler or something like that, yeah. We'll kind of lock this in, and then the width is the width. And the nice thing about this is if you can make multiple types on here, and the height is the height. Ba-boom. Okay. You can go ahead and make multiple types if you really have to. So I'm just going to delete this bad boy, and from a front view we want our rail. So there's our rail height, and then our overall air handler height. So this is our air handler height, AHU height, and then we'll do the rail here. Boom, rail height. And this one should be locked. Is this one locked? Yeah. Then we can move all these up. And you could use the move command, or you could use the align command. It's the same thing. It won't change the boxes. Okay, and then I'll move the door out of the way here. Now, as far as the lengths go, that's where putting in the overall length here kind of helps you, right? Because sometimes you won't get very good information on here. And this one actually gives us real good information for this length here, but not really good ones for the filter box and things like that. So we'll just say that the equipment housing is 49 7/8 long. So 49.875 inches. So there's our length. And then the other ones, we'll cut this in half here, this 90. We'll cut it in half, and then we'll cut it in half again for this one. Yeah. So, and we'll just call it, so 90.125 divided by 2 is 45 and 1/16. So that's our filter section. 5.0625 inches is the length here. And then if we wanted to, right, you could say equals 45.0625 inches divided by 2. And it does the math for you, and then we can just copy from that one into this one. Boom. Boom, and then we'll move all this into place. And then the last thing we need to do is build our rail on the bottom. And that's real easy. That's just an extrusion, kind of matching everything. And I'm not going to spend a whole lot of time on getting it planed up and stuff. Boom. So there's the air handler boxes, and it kind of looks real good too. You can see what section's the cooling coil section, etc. Again, I should probably make a fan section one. And then as far as the doors go, we have 2 doors on the UV section, 2 doors on the equipment section, and 1 door on the filter box. So from a plan view, and it looked like we had 20-inch doors and a 27-inch doors. So I'll duplicate this. We'll call this a 20-inch, and this is 20 inches. Okay, makes it a little bit smaller for us. Copy, edit type, duplicate, 27-inch door, 27-inch door. And then as far as the heights go, you know, we'll guess 70 inches, 64. We'll just call these 5-foot high doors, you know, just for good measure. So when we look at the types on here, the door heights, we'll just call this 5 feet. Switch it out to the 20, call this 5 feet. Okay, so that gets our door heights for us. We want a 27-inch door on the filter section here, a 20-inch door here. And you know, again, you'll probably spend more time if you're actually building these. It looks like these doors are backwards here. So I'm going to take these, move them to here. Oh, I thought I had both of them. Right into, line these up. And what's cool about this is it kind of gets your swing clearance on there for the door, just to make sure, you know, all is right in the world. And then we'll go to a front view, and make sure that our doors are sitting right. I mean, generally speaking, I would say they're probably okay. But I'll just move them up slightly, and then let's look at what this bad boy looks like. So pretty quickly you have a pretty nice air handler with doors and everything, you know. Let's go ahead and add our clearances on here. Oops. Model line, hidden lines. And by rights, you should probably make a dimension on your clearances. So if you kind of go into here, we can call this clearance width, right? And then usually they're like 3 feet, it could be 4 feet. Oops, I'm looking for clearance width. We'll just put 3 feet in here for now. But boom, there's that clearance. Create model line. Add this dimension, set it to clearance width, ba-boom. And so we can start getting, you know, our clearances on here. If you wanted to model the clearances to save space, you can create your extrusions off of your model lines here. So extrusion here, lock all these in. Extrusion here, lock all these in. Boom. And then set the height of this bad boy, probably from a front view. Set it to your air handler height. So you can see how having all these planes in here comes really in handy at the end of the day. And then here we need to make sure we set our visibility. We don't want to see this in any of our orthographic views, just in the 3D view to save space. The other thing we want to do is see if we can add some sort of a glass material to this so it's transparent. Yeah. So glass is kind of usually in a mechanical equipment family. I've seen a lot of, as far as materials go, a lot of people make their clearances red instead of blue like this glass. And by rights, you could just duplicate this and call this clearance. Right. And then in our object styles, manage object styles, if we made a subcategory and called it clearance, and then we said dashed here, and we called this red. Now when we set the subcategory of this bad boy here to clearance, it'll kind of take on, you know, that that appearance for us too. Same thing here on these lines. So what do I have selected here? Oh yeah. On these lines here, if you set the subcategory to clearance, you'll get the same appearance in the plan views and stuff as well. Yeah. So if we loaded this in, oops, this one didn't get selected, and set clearance. So if we make a project, I'm just going to load this in. We'll make the connectors here in a second. How much time we got? Like 20 minutes? Okay. Load this into the project. So you can kind of see the way that the clearance subcategories and things function, and the way that the different boxes here kind of give you what you need from a graphical perspective. Yeah, and then everything again is everything again is modeled in 3D, so you can see your clearance in the 3D view, and you can run Clash against these as well. Yeah, that's why it's important to have both your model line clearances and your 3D box clearances. They kind of do separate things. They serve separate functions is the best way to do it. You just have to make sure that inside of your family, you're setting your visibility graphic settings here as far as where it gets displayed. Because if this is turned on and we load this back into our project, overwrite. See how it hides the doors? I mean, the doors are there, but it hides them because the 3D object is technically on top of them. Okay, now if we have that set, if I just hit undo like we unloaded our family, you get kind of the functionality that you want out of the object. Yeah, even though it's the same object, it's literally just changing your visibility checkboxes here. Okay. So now let's look at this same sort of a scenario to adding our rectangular connectors. So in here, there's also a rectangular connector. So we'll drag and drop this in, and we'll load this into our family 3. Ba-boom. And this is literally just a box, okay? So if I actually went into this, it's just like all the other ones, it's a box. There's a length and a width on it, outlet width, outlet height, and then there should be an extension off the front. Yeah, outlet length. It's literally just a box, okay? And this is what we call nesting families, when you have a family inside of a family and you get familyception here. Go Leo on us. So I'm going to go ahead and put this based on where our connectors are. So we got a 64.5 by 20.25 and a 29 by 65. So we got 2 connectors. They're kind of close, but they're both sitting on top. You could rotate this and put it on the side as well. But what that means is you need 2 types. Okay, so if we say edit type, I'll duplicate this and I'll say supply connector or supply outlet, and duplicate this for return outlet. If you had an outdoor air connector, you could do the same thing. Outlet, ba-boom. So the outlet height on the return is 20.25. The outlet width is 64.5. And then the supply, we're looking at 29 inches. And the width is 65 inches. And I usually put 1 inch on the outlet length. That's the extension. Kind of depends on how the connector is. Most of these air handlers, you sheet metal guys will kind of know. Some of them have lips. Some of them, they just turn out a flange and screw to the equipment. You'll kind of need to determine that yourself. But in general, why it matters is because it matters where you put your box connector, okay? This is shown flush, so I'm going to assume that they're just going to come in and put turn a flange out and connect it to the equipment like this, yeah? So click OK. So this is our supply. Let's copy this and make this our return. Rotate this up. And again, if you're doing this to where it really matters, like we're building this actual thing for, you know, modeling and all that stuff and fabrication, spend the time and check the dimensions and all that. I'm just going to leave these here for now. It looks kind of close. And then get these elevated properly. Yeah. Since the extensions are the same, oops, I think I have to move these independently. Yeah. 1, 2. Now again, from our family session the other day, oops, I made a mistake. So these are set to, trying to understand why these are like this. Visibility graphics. It's got put on the clearance subcategory for some reason. I'm just going to leave it, but I'll have to figure out why it's on the clearance subcategory. Anyway, so what we were learning from our previous training is that connectors, when you put them on an object or an extrusion, a face, they always center themselves in the center of gravity of whatever face you're on. So if we go here and here, you know, here's where we could start making other dimensions. Now, if we used a parameter to drive the dimensions of these boxes, it would also be the same parameter that would drive the dimensions of the connector. And you could map those in. Yeah, so let's just do that. I'll just do the supply. So we would say SA width. We can call it type-based SA height. Boom, and then the width was 65, and the width or height was 29. So you could actually, again, you could map these in. So supply, the width is SA width, and the height is SA height. And hopefully I did that right. Looks like I did it backwards, but I'll just rotate this. No one will ever know. Don't tell no one. So the height, SA height, and SA width. And then again, you could do the same thing on the return. I'm not going to worry about it. We'll just call this, I think it was 64 and a half. Oops. It is 20 and a quarter this way and 64.5 inches this way. Boom. Right. Cool. So let's load this back in. See what it looks like. Overwrite. And you can see you have your connectors here. Now what's interesting is we mapped the parameters here on this, looks like it did it on the return side. Oh, that's the other thing I forgot to do. I was getting too far ahead of myself. This is supposed to be the supply side. You want to set it to supply. And again, this is going to be out. Supply is always out. Return is always in. Return is in. This is return. Boom. Let's load this back in. Overwrite. And what you'll see is, you know, you have in and out showing on the connectors now with the right symbols, and you can see what the size is. Now what's real interesting about this is I set these as type parameters, the width and the height. If you go in and you actually set these parameters to instance parameters, you can update these on the fly. So if I change this from a type parameter to an instance parameter, this is real important when you get families in from manufacturers and they have like a really weird connector size. Maybe it's like 55 and 19/16 or something. I mean, all you sheet metal guys know they just round it up to 56 and turn out a flange, right? But you can see here the dimensions aren't grayed out anymore. So if I wanted to change this to 30, so we didn't have any odd sizes, since we're just going to turn a flange out anyway. Oops, 666. 66 inches here. You can go ahead and do that and your duct will connect to it using that size, okay? This is really powerful from a modeling perspective later on. It's less maintenance. Yeah, you don't have to get in and out of your family and all that stuff. So doing a little bit of stuff up front on these families will really save you on the back end. Now, obviously, I didn't map anything on the return side, so it's just kind of stuck here. So if I just hit return and it's going to start drawing ductwork, I could change the size here, but it wouldn't change anything on the equipment. Yeah, so if I set my offset to like 15 feet and we started drawing, I don't know, I don't even know what I was drawing on. Doesn't really matter, but we can kind of see how powerful this is, yeah. So there's our air handler family, yeah. Are there any questions on this while we have just a little bit of time on anything from anybody? Again, the most important thing is just understanding subcategories, reference planes, and dimensions. If you get the difference between type and instance-based, and you understand kind of how to map these and nest families and things, you're going to be doing really, really well. Yeah, you're going to be doing real well. Yeah? Nothing?
Man, I can watch you all day.
Hey, thanks, man. Thanks. I've had lots of practice, but yeah, this is good stuff. Yeah, this is good stuff. If you if you understand the difference between the different parameters, and you really start driving into understanding your reference planes as you build things, you can be really dangerous. You can model things really, really, really quick. Yeah. So, thank you. Anything else from anyone? We might just call it early if there's no other questions. No?
The flow is how critical is the flow to assign it?
Oh, that's a good question. Okay, so flow in general, unless you're doing engineering workflows, to be honest with you, it doesn't really matter. And this isn't really uh, like a connector engineering type thing, but if we look at it right, the way that it actually works is Revit is built to do the calculations for you, and what they have is what they have for connectors and the way that all works is you have what's called a source connector. Okay, and then you have target connectors, and in a system you can have multiple target connectors, but you can only have one source connector. So I'm calling my six-sided thing my source connector here, and then it will go connect to all of my target connectors. Now, depending on like Eric, since you're a sheet metal guy, we'll use a sheet metal reference, like an air handler, for instance, right? Say you have an air handler here, and these are all VAVs. So your air handler would be your source, and the VAVs would be the target, okay? And the air flows one direction always. So on the connector for the outlet, say the supply on the air handler would be an out, and the connector on the VAV, the inlet, would be in. So it flows one direction, yeah? Now, on the return side, you have all of your, so, you know, that's the air handler supply side. Now, downstream of that, you could have multiple air devices. Maybe I should make that a little bit bigger. So maybe one VAV serves 3 air devices, okay? So on the VAV itself, you have an inlet and an outlet. So here's your target and your source again. Your target connector would be the outlet. I'm sorry, the source connector on the VAV would be the outlet. So that would be out. And the target connectors would be your supply air diffusers. That would be in, yeah? So everything is always flowing in the same direction. And that's how the systems are broken up and actually driven inside the software, okay? On the return side, you know, basically all of your air devices would be target connectors, and the air handler would be the source, even though the flow is backwards. Okay, so that's why you have in on the return and out on the air devices. Even though the flow is actually going into the return air devices. It's a little confusing, but if you always think about the flow of the information, that's what's important. Okay. Does that answer your question?
Yes, sir. Thank you.
Cool. Yeah. And we can get deeper into that. Maybe we should do a class on that too. Where it really you can really get into the weeds on it is if we start actually using the systems to calculate our CFMs and things like that. So maybe we'll do something on that later. But
So
Revit uses systems. Yeah.
for modeling perspective, it doesn't matter then.
Not really on the shop drawing side, no. We could actually get in here and model systems and track CFMs and stuff, but it would just be an extra for almost no reason, I think.
All right, thank you.
I personally just like to do the in and the out on the equipment, so I know what direction the air is flowing when you look at it. Yeah. Makes it a little bit easier, especially when you're doing like a like this here. Like something like this, it's good to know which ones are going in and which ones are going out on a big tank like this. Something with like, you know, over 3 or 4 connectors, it's good to know. It can get confusing for sure. So cool. Any other questions? Those are good questions. Nothing? All right, guys, that's it. Let me know if you guys are finding value in this or whatever. But we'll do something next week on annotations and keynotes. I'm sorry, note blocks, and I will talk to you guys later.
Thanks, Bertie.
Yep. Take it easy.
Thank you.